Welcome to Nole, the official podcast of the College of Arts and Sciences at Florida State University. I'm your host, Amy Walden with the College of Arts and Sciences, and today we welcome Daryn, Sagel, and Bryan Quaife with the Geophysical Fluid Dynamics Institute right here at Florida State, also known as GFDI. Daryn and Bryan, welcome to the show. Thanks for coming.
Thank you for having us.
Yes, thank you very much.
So on today's episode, we're talking about the Fire Dynamics program at GFDI in the College of Arts and Sciences and the research being conducted right here in Tallahassee that's helping forestry specialists around the country better understand how wildland fires move and spread. This research is not only used to help inform controlled burns, but also to mitigate devastation when wildfires do break out. The Fire Dynamics program is a collaboration between several different departments on campus, including the Department of Earth, Ocean, and Atmospheric Science, the Physics Department, the FAMU FSU College of Engineering, and the Department of Scientific Computing, which is where Bryan Quaife is an associate professor. Bryan is also the advisor for Daryn, who is one of the graduate students in the Fire Dynamics program. So Bryan, we will start with you. Can you talk a little bit about how the Fire Dynamics program began?
Sure. So GFDI has actually been around for quite some time. It was formed in, I believe, 1967, and traditionally it looked at a lot of meteorological and oceanographic type applications. But about 10, 15 years ago, there were two PhD students that did research in fire dynamics, and this is kind of the very beginning of the formation of the program. At this time, the director, Dr. Kevin Spear, he started to envision building this fire dynamics program, and so he did this by recruiting some junior faculty, of which I was one of them back in about 2016. And then we brought in some PhD students and some UROP students and also some undergrads, which Daryn was at the time, and then eventually secured some funding from the Department of Defense. And the program's just grown ever since then. And so I'm actually also very happy to announce that we actually graduated our first PhD student from the program just back in April, and he's now a postdoc still working in the field at Los Alamos National Laboratory.
That's terrific. Congratulations on that. Daryn, you're a student in the Fire Dynamics program at GFDI, and you actually fly drones over fires as part of your research, which we're going to get to a little bit later. But first, I'm just curious to know how you first became interested in studying fire dynamics.
Yeah, it wasn't something that I had planned to do or expected to do. I don't even think I knew that the field existed before my senior year of undergrad. But initially, I actually came to FSU because I was interested in film and animation. And then when I first started here, I started getting interested in physics as well. So I was like, I'm going to do the physics program. And there I was introduced to GFDI, where, you can do a bunch of experiments to study different fluid flows. And a lot of those use cameras to record what's happening or to capture certain things. And Bryan and Kevin Spear both knew, Daryn really likes cameras. Let's give her this thing to do. Let's just introduce her to it. I did something called particle image velocimetry, which is basically you have some fluid flow, you put particles in it, you shine it you light it up with a laser, and then you use a camera to capture what's going on. I was like, oh my God, I love this. This is the coolest thing I've ever done. It's really pretty. Forget the science part of it. This looks awesome. And so I kept doing that. I kept working with cameras. And eventually, when the fire dynamics program was picking up, they're like, hey, why don't you try applying it to this? And so I got into, using cameras or flying drones or whatever I needed to do at different prescribed fires to capture the information we needed. So same thing as with the little fluid tanks, still very pretty, but a little bit different setting and application.
That's so neat how you first got into it. So the program is very interdisciplinary, as we mentioned earlier, with coursework spanning everything from statistics and mathematics to engineering and even meteorology. Bryan, why do you think this multifaceted aspect of the program is so important?
Sure. So fire dynamics is a very multifaceted type problem. There's lots of physics going on in here. And so we need to be able to rely on expertise of meteorologists that know something about, say, how the plume transports, or engineers that might know something more about the heat transfer, or computational scientists like myself who are interested in developing the software tools to do these types of simulations. The program is, because there's all this different physics going on, this is why we need people with all these different expertise. But this really works to the benefit of our students. They come in with particular interests, such as Daryn, that was interested very much in some of the computer vision stuff very early on. But we have other students that are more interested in, say, looking at it from more of a computational fluid dynamics type lens. And so what we're actually able to offer students in the program is to do a few core courses, but then really kind of tailor their coursework towards the tools and to experts that kind of can help them with the kind of research that they want to do. But in addition, it's very important that our students see, look at fire through different lenses, and this we accomplish by having weekly or biweekly group meetings with all the students in the fire dynamics program, which range from engineers to statisticians to applied mathematicians to computational scientists.
That's great. And speaking of students, the students in the program get to work with both state and federal agencies to conduct their research. Bryan, can you tell us who the program partners with exactly and what these students get to do with the agencies?
Sure. So we've worked a lot with two local land conservatories, Tall Timbers Research Station, which is just north of Tallahassee here, which is where we had the prescribed fire recently. And then there's one in South Georgia at the Jones Center at Itchaway. We've used these agencies to collaborate on papers together. They have kind of the burn managers that can actually do the prescribed fires that we can go out and take measurements at. And they've also supported us through internships, which Daryn has done with Tall Timbers. We've had other students work with these land conservatories. In addition to the land conservatories, we also work fairly closely with the Los Alamos National Laboratory. As I mentioned, my one student that recently graduated, that's actually where he is right now, but he was actually also there for the majority of his PhD. And so Los Alamos actually has a collection of different computational tools that are considered to be kind of leading edge across the world for simulating fire and related physics. And my student worked on exactly one of these software tools, and he's continued to develop it now in his postdoc. And then finally, we've had support from the Department of Defense under what's known as SERDUP. It's the Strategic Environment Research and Development Program. And so this has supported students and postdocs here at FSU, as well as collaborators at Tall Timbers and Los Alamos and the Rochester Institute of Technology, for us to be able to study a problem related to, a problem in fire science, which is about understanding what's called the near-field plume.
It's fantastic how many partnerships the program is involved with. Our Nole Edge crew had the opportunity to attend a prescribed burn at Tall Timbers a few weeks ago. Both of you were on hand to take some drone footage and analysis with something called a firebox. Daryn, can you tell us more about how those two pieces of equipment are used to monitor the fire?
Yeah, absolutely. So I'll start with the firebox, which is basically a metal box with insulation inside of it and a data logger that's connected to 3 thermocouples, which just measure the heat or the temperature of wherever they are. But a problem sometimes with putting instruments in fire is that they will burn. So it's all sealed together within the box, and there's this aluminum block that lets the heat transfer to the thermocouples but not get inside of the box. And with that, we can measure, heat flux, things that are important to either fire practitioners or modelers, depending on what they're looking at. And so we kind of coupled the measurements that we take there with measurements from the drone, which flew above the fire. The drones we used, one of them was borrowed from the Jones Center, and the other one was operated by someone from Tall Timbers. And both of them have a visual and infrared camera, so just a normal picture and infrared. One of them was closer to what's called mid-wave infrared, which is just a better job of capturing the fuel or the fire itself and not so much maybe the smoke or the plume, which Bryan mentioned we're also interested in. And so the other one has it measures in long wave infrared range, which means it does a really good job of capturing, it has the fire, but it also has the smoke around it. We can use both of those together and with the firebox measurements to kind of have a fuller picture of what's going on. And we can extract values from that and use it to inform our understanding and also fine-tune or adjust different computer models that are developed.
Yeah, getting to see the screen on the drone was something really cool, and I had no idea that's what it looked like. So thank you for letting us tag along. Bryan, what are some of the ways the research being conducted at GFDI is actually helping forestry officials when it comes to these wildland fires?
So a lot of fire science that's used by people like land managers, a lot of farmers use it actually to manage their crops. And people like this, they rely a lot on experience and information that's been passed down from generation to generation. But what's happened very recently is actually due to many factors, including climate change. the behavior of fire has changed. And so, there's a somewhat famous example that happened last year in 2022. There was a prescribed fire in New Mexico that was supposed to be, small and controlled, but then it escaped on them. And it ended up being the largest fire in the state's history. And this happened because of, unexpected droughts and unexpected winds that happened at that exact time. And so what's clear is that there's a need to bring in a science basis to help with the understanding of how fire and smoke and plumes behave. And so this is what we're trying to do here at GFDI and with our collaborators.
That's wonderful. Bryan, what kinds of careers does the fire dynamics program prepare students for?
So some of our students can certainly go to things like national labs, like Los Alamos, like my student that graduated quite recently. But Los Alamos is not the only place the only lab that's interested in fire science. NCAR is certainly interested in fire science as well as other national labs around the country. I often get job ads from my colleagues at the Jones Center as well as at Tall Timbers when they're looking for maybe a postdoc or maybe just a lab technician. So something that doesn't require a PhD, but maybe a master's student or something like this. But something that we really try to ingrain in our students in both GFDI as well as scientific computing is that we're not giving them skills that can only be applied to one particular application. And so if a student is looking at fire from a computational fluid dynamics kind of framework, then they could certainly apply the same tools that they had to maybe a completely different field like oceanography. Or if they have experience in something like remote sensing or flying drones or this kind of stuff, then maybe it would be applicable to someone that's interested in something like atmospheric chemistry.
Those transferable skills.
That's
yeah,
right.
Absolutely. This question's for both of you. What do you think is the most common misconception people have about wildland fires?
So I certainly had this misconception myself but before I started doing this research. And it was that wildland fire is kind of this disastrous bad thing that we see in the media all the time. But wildland fires actually includes prescribed fires or controlled fires, which have particular goals. And so the most obvious goal that people think of when you do a prescribed fire is that you're trying to remove all the highly flammable buildup that, if ignited, could lead to a catastrophic event. You're typically trying to get rid of the litter on the ground, or depending on the type of forest, they have ladder fuels, which are fuels that allow fire to propagate from the ground up into the crown of the tree. And so, eliminating these is an important thing to do. But in addition to reducing the risk or mitigating the risk of fire, there's also certain species that rely on fire, especially here in the Southeast. A famous one that we hear a lot about is called the red cockaded woodpecker. It was nearly extinct I believe in the 1970s, but by using fire in the longleaf pine forest that we see around here in the Southeast, as well as some very invasive type strategies, they've been able to revitalize this woodpecker, and they're still very endangered, but they're doing much better than they were, say, 30 years ago.
That's terrific. Daryn, did you have anything that you wanted to add?
Yeah, I think my I don't know if it's a misconception, but unexpected thing goes along a bit with some of what Bryan's been saying, but it's just the sheer number of factors that impact how a fire behaves. So there's, the topography, so how flat or hilly it is. There's obviously like the climate of the area and what kind of plant species there are, what the general weather is, so how humid it is, where's the wind going, how is it behaving. But it's also things like not just time of year, but what time of day are you burning? If you burn in the morning versus the afternoon, you have some significantly, different effects, or it plays out differently, or like where the fire is ignited or the pattern that it's ignited with. Just so many teeny tiny things, or like seemingly tiny things. What is the forest canopy shaped like? So how close together are the trees? Are the trees more like leafy or pine needly, or like all of this affects how a fire plays out, which I don't think is like, it's not the first thing you think of when you're trying to predict how a fire is going to behave, just how many little things you have to think of. But the thing that I think makes that a little interesting is whenever I talk to people about what I study, I'll get a lot of like, oh, I bet you wish you were in, some place that gets these really big fires. But actually, because of the specific combination of factors that we have here, the Southeast is a great place to be able to study fire and have the controlled burns. And since there are ecosystems, plant and animal species that rely on it, this is a great area to study also kind of like the more ecology side of fire, not just the physics. And that's not something I expected or would have initially thought before I started doing it.
So Daryn, based on your experience, what would you say to a student who might be listening right now who is maybe interested in the fire dynamics program?
Okay, I think this is kind of along the same vein, but there are a lot of different things to study in fire. So Bryan and I are maybe a little biased. We both do like physics and math and fluids, and that's most of what we look at, like coding. But there's a huge side of it in like chemistry or geography, or there's even like a social science side, so how different populations respond to fire. Or if you're interested in like traffic flow, which is like fluids and statistics mixed together, or like natural hazard response, there are people who study evacuation of certain cities, like the effectiveness of their evacuation plans in the event specifically of a fire. It's such a multifaceted problem that if you have an interest in it, there's almost undoubtedly like an area for you to work in or apply yourself to. Like I was interested in film and I ended up here and I do like everything that I like doing. I think it's one of those things where it sounds like a really complex or intense problem, but kind of just like everything, if you spend time on it, you're willing to put in the time to learn what you're doing, you can make incredible contributions to this field and advance a really important area of research. And it needs researchers because there's so many little parts and moving pieces that we need to work together to figure out.
So that takes us to how we end every podcast, which is with our bowl of mystery questions. So Daryn and Bryan, go ahead and draw a question and you can both respond.
These are going to be the hard ones.
I got, what's your favorite place on FSU's campus? I like just going for a walk around campus after lunch. One of my typical paths is I go wandering up and down all those sidewalks in Landis Green. Just kind of, you can almost do a whole mile just kind of weaving up and down from the library and then from there. Yeah.
It's almost hard to pick a favorite spot because they're all great. Daryn, what about you? What'd you get?
Have you played any sports and do you play any currently? I used to swim, but I've actually joined FSU's Ultimate Frisbee club team and also community league that we kind of help run. But yeah, so Ultimate Frisbee, is kind of similar to fire research. I hadn't heard of it before I started. But now that I have, it's a huge and really nice community, just like the fire, just something I didn't expect so many people to be part of.
That's terrific. I need to learn the rules of Ultimate Frisbee after the podcast. All right, Daryn and Bryan, thank you so much for joining us today on Knowledge. And if you would like to learn more about the Fire Dynamics program at the Geophysical Fluid Dynamics Institute here at FSU, visit gfdi.fsu.edu. Thanks for tuning into Knowledge, and we'll catch you next time.